All right, hello everyone, and welcome to today's webinar on flexible and open source silicon photonics for academia and industry. My name is Prithvi, and I'm the business development manager at Wave Photonics. I'll be the host of the webinar for today. First of all, I'm delighted to have you all join us today. We are excited to bring you presentations from our speakers, Emre Kaplan and Matthew Anderson. Emre is the PDK manager at Cornerstone. Cornerstone is an open source license-free silicon photonics rapid prototyping foundry. With their open model, Cornerstone lowers the barriers to design, fabrication, and test new ideas in photonic integrated circuit chips. And our other speaker is Matt. Matt is the co-founder and chief scientific officer at Wave Photonics. Wave Photonics has developed a core computational design technology that can develop application-specific PDKs for any wavelength and platform to fast-track development for customers working on data comms, sensing, and quantum technologies. So for this webinar, what we'll do is we'll begin with Emre introducing Cornerstone's platform or service offerings and also their PDKs, followed by a live demo of the PDK management platform by Matt, who will also show how designers can access Cornerstone's PDKs through the PDK management platform and how foundries can also use the same platform to upload and manage their own PDKs. So before we get started, a quick note, you can also post any questions anytime using the Q&A box. We'll address them at the end of the session. Now I'll hand it over to Emre. Emre will share about Cornerstone's platform, their PDKs, and how you can access their services. Emre, over to you.
All right, thank you, Prithvi, for the introduction. Let me share my first screen. All right, if it is okay now, so I can start. Hi everyone, actually introduction, I'm Emre Kaplan from Cornerstone, working on PDK developments of the technology platforms. And I really like to thank you, Wave Photonics, for giving this chance to talk about Cornerstone and our PDKs. So what's Cornerstone? So we are license-free open source silicon photonics foundry. We provide different various platform to cover visible telecom and mid-air wavelengths. So you can here see our portfolio of services and platforms here. We have 3 different thicknesses in silicon on insulator platform. We have germanium on silicon and suspended silicon for mostly designed for mid-air applications. And we have also silicon nitride platforms where actually we recently introduced very newly at the 200 nanometer thickness nitride. So in addition to core technology platforms, we also provide deep UV lithography service. So if you are just interested in lithography, and we can do that for 8-inch wafers. Cornerstone is a collaboration between the University of Southampton and Glasgow, and the team at Glasgow, they are working on the light source integration on chip by using pick and place technology. And also another service that we are currently working on to launch is the flip chip and wire bonding. So if you need to go really higher speed modulation, then you really need to bring photonic and electronic chips close to each other. To do that, flip chip method is one of them, where you can have your electronic IC placed on top of the photonic IC, where you can control them. Of course, you will have wire bonding for the electric connections. We are basically a member of Europractice and JPIX brokers. You can find our MPW schedule and cost on their websites. We recently became a member of JPIX, that we are quite happy of that. We are working right now on the JPIX portal to introduce our PDKs. So there are 2 modes of access to the technology that we offer. The most cost-effective way is, of course, multi-project wafer runs. It's just because we provide standardized technology and they combine various different designs on a single wafer. So you basically share the total cost of fabrication with other designers on a single wafer. And it is really useful for proof of concept and early stage of R&D. So you think that silicon photonics or integrated photonics in general can be a solution to your problem, and you really need to quickly test your idea, then the multi-project wafer runs are designed for that. It's suited for researchers, PhDs, startups, SMEs. And on the other hand, if you are interested in prototyping your device or perhaps like a larger design area or a little bit customization in the fabrication step, then the bespoke fabrication runs are suitable for these purposes. Of course, the entire wafer will be dedicated for your design, where you will have more samples, die samples for your testing. So looking into the platforms that we offer, silicon on insulator is the main and fundamental one. It's still popular in datacom and telecom applications. We provide three different thicknesses in SOI, like 220 nanometer, 340, and 500 nanometer. So basically, the 500 nanometer is actually removed from the MPW schedule this year, but we still provide that platform through bespoke batches. Here you can find uh, two types of runs, passive and active. In the passive batch, you have an option for the integrated heaters, where the active batch provides also implantations of the silicon layer. So you can create your own PN junction. It's mostly for carrier-based modulators. So all these batches, we provide three different silicon etch depths. One is for grating couplers, but two of them to form shallow etch or fully etched waveguides. So if you are interested in rip or strip waveguides, there's an option to go into the deeper etch to actually do the full etch for the strip waveguides or shallow etch for the rip waveguide types. So all the process design documents with the standard components are also available. And the next platform is the silicon nitride, which gains quite a lot momentum in recent years for some certain properties. So this is the first nitride platform. We started with the 300 nanometer thickness. It has actually wider transparency window compared to SOI. It covers visible up to mid-AR wavelengths, and it provides lower losses in O band and C band uh, compared to again silicon and insulator devices. It makes it for this property quite useful for quantum applications. If you hear people working in the quantum field, they really need low loss waveguides where the silicon nitride can facilitate this requirement. And low term optic coefficient is more or less 10 times lower than silicon itself. So it makes the devices in silicon nitride platform are more robust to the thermal fluctuations around the chip and devices. Of course, on the other side, it makes it quite difficult thermally tune your circuits, but silicon nitride is preferred for uh, some sort of applications where the response of the devices and circuits are less affected by the changes in the temperature. And for nonlinear optics as well, nitride is quite useful because there's negligible two-photon absorption effect where it made quite significant in SY structures. Therefore, people are working in the nonlinear optics. They are also having more interest in the silicon nitride platform. The one that I mentioned previously, the new platform, we actually launched it in July this year, and we are running the first MPW batch. It's based on 200 nanometer nitride thickness. We initially target visible wavelengths like green and red. Then, of course, in the future, with more data, we try to expand the wavelength range. It has the same features that I previously mentioned for 300 nanometer thickness platform, but if you go below 1 micron in wavelengths like visible range, then you can design your devices for biosensing applications. Um, you may know that these biosamples like proteins, DNA, and RNAs, they are mostly interacting with light, visible light. It actually allows you to design your own biosensor on chip. The next platform is called suspended silicon. Silicon itself is transparent to up to 8 micron, but when you put it on an insulator, in this case silicon dioxide, which is quite absorptive on the 4 micron and longer wavelength. So in order to fully exploit the transparency window of silicon, we just need to remove the silica underneath the waveguide. So how we do that is we basically create a kind of grill shape structures. They are called support structures where the light propagation happens in the main waveguide right in here. And we do undercut etching by HF where you remove the silicon dioxide layer on top. Then you actually increase the transparency window up to 8 micron. So it is useful for sensing applications in mid-AR, and also the process itself allows you to design your own optical MEMS devices. And the last platform we have at Cornerstone is germanium on silicon. It has the largest transparency window, actually from 2 micron to 12 micron. We provide 3 micron thickness germanium in the platform where you can have single edge depth to form RIP type waveguides. This platform is also useful for biological sensing, especially for gas sensing, like greenhouse gases. Absorption peaks are mostly within the mid-AR range. Then this platform quite useful for this kind of applications. So the next is the the service that we are working on, flip chip bonding of electronics. Um, so we have a new tool in the clean room right now. The colleagues are working on optimization and creating this process. It is mostly for electronic chip onto the photonic chip and then the wire bonding to the PCB. So by doing that, you can have modulator drivers on the photonic chip. And of course, in a general context, you can control your photonic devices and circuits with electronic devices very close to each other. So this is then an option to increase the modulator speed in general, make them optical domain and electrical domain close to each other. And the last service we are working on currently is the pick and place of light sources. Actually, not only lasers, 3.5 lasers, we are working on also photodetectors. Actually, we made the trial tests on PDs at the moment, but the next step will be the 3.5 light sources on silicon or silicon nitride chip. The colleagues from University of Glasgow are working on this process, and we are expecting to have concrete results by the end of next year. And typical applications, transceivers and lidars, it is because you have your own light source on the chip and the passive circuitry and the photon detection. So this three functionality on a single chip that allows you to create your transceivers and lidars. So if we look at the general spectrum coverage of Cornerstone platforms, we aim to cover the visible wavelength range up to 14 micron provided by germanium on silicon. You see here the cross sections of the technology platforms right here. Of course, in the SOI case, the limiting factor in the wavelength range is the oxide itself. So after longer wavelength than 4 micron, it's quite absorbing and creates extra losses in the waveguide. But by removing that layer, then you can actually have the full transparency of the silicon waveguide. So it actually tells us one thing. Depending of your applications wavelength, of interest or the optical power budget or electrical power budget, the footprint of the devices, you see the, the diversity is huge here. So even in early stage, before going to any foundry and even before designing your own chip, you really need to choose the correct platform that that provides also, let's say, the most suitable for your requirements. This is how it works in integrated uh, photonics as opposed to electronics, because in electronics you have two fundamental materials, silicon and germanium. But when it comes to integrated photonics, this diversity is quite advantageous to increase the number of applications. But at the same time, you really need to choose the platform wisely right at the beginning to fulfill your requirements. So talking about the process design kits, they are actually useful to accelerate the design circle. So they act a kind of interface between a designer and foundry. And you don't really necessarily be expert in photonics to design your own chip. It's just because in the PDKs, you will find quite comprehensive information about the fabrication itself, but also some fundamental devices. They are called building blocks, where you can use them, connect them to create complex circuitry. So typically you find these fundamental blocks, design rule check scripts, and the simulation and test results as a compact package provided by the foundry. Then you actually start doing the designing your own mesh layout. So here there is an example of Mach-Zehnder interferometer. So we start with the circuit schematic. This is an idea that we like to implement, right? Then it consists of several different building blocks like couplers for light and in and out, splitter and combiner. They are mostly 1x2 MMIs. You have bands and waveguides. And these individual components are actually provided by Foundry, and you know their transfer function. So process design kits really eliminates this the effort and the time spent on the simulation and optimization of individual components, rather than you can focus on the innovation or circuit level design. And then once your mesh layout is ready using some software tools, then you get access to the fabrication through MPW or bespoke runs to get your own fabricated chip. So here an example in the SOI active batch 220 nanometers. So this platform provides implementation of the PN junctions where you can create your own carrier depletion modulators. So what you expect when you have a building block, it is a design, the mask layout of the component itself. Here you see also the fabricated device image and some specifications provided by Foundry. So if you are interested in high speed, in this case, this modulator supports up to 28 gigabit per second transmission, and some more information about the device itself, insertion loss, extension ratio, and also the cross section of the final device. So you can use either uh, um, as a you can use either a kind of standalone device. You can have it on chip, then you have a modulator that supports up to 28 gigabit per second, or you can start as a starting point to design your own modulator. So this gives you kind of a starting point. Or you can even use this component as a part of your complex circuits. So these are the main functionalities of building blocks, that they provide a specific functionality or even circuits specific functionality for you. Then you can use it as in your design as a singular component or a part of larger circuits. So where to find our PDKs? Thanks to the Wave Photonics PDK management platform, right now we have our PDKs available in more design software tools. Here the Lucida Photonics Cadence, GDS Factory, Siemens. We also provide the layouts. You can actually use K layout. It is license free, then you can straight away start using it for designing your chips. Lattice Design Systems recently added from Pick Studio, and we are currently working on the PDK integration into Synopsys software tools. Of course, each of them has specific features you can opt for. Uh, some of them provide both mesh layout and simulation. Some of them provide only mesh layout, and they are all available on the Wave Photonics portal. So if you visit cornerstone.wavephotonics.com, then you will have access to our PDKs. Then Matt will show also a demo later. So before going to conclusion, I'd like to share our initiative. We have recently launched it in Copenhagen, Denmark at ECOC conference. It's called Open Platform. It's basically a GitHub repository, the extended version of sharing just the layouts and designs, but in a larger extent, we aim to share even more information about the platform itself. So they will be the test results associated with the components. There will be some metrology data coming from the clean room measurements, open fab. It's about the process itself. Like we will share even the CDSCM measurements where you can actually have the information on the fabrication variation. So we become truly open source by launching this open platform, and we are quite thankful to early contributions from Tyndall National Institute, CSA Catapult UK, University of Pavia, and University of Sheffield. So the main idea is there's a single point of sharing knowledge in integrated photonics. So you have designed your own device, you have published everything about it, but it can be still useful for some other applications or in the future, uh, let's say designs used by some other designers as well. So please consider to join this campaign. We will launch at ECOC and it is already live on GitHub. There is actually the instructions you can find on our GitHub repository. So if you navigate Cornerstone repository on GitHub, you find our core PDKs, and in addition to that, also the open platform contributions. So you can either download your chosen design or upload your own design. So if you are interested in contributing to open platform, there is a checklist that you can check on our website here to complete them, and then you just need to create your pull request on GitHub. This is the most technical part of it. If you are not familiar with GitHub, there will be enough information on our website. And then we encourage people to share some supportive documents about the building block they share with us, like paper uh, results, simulation, and test results. Of course, you will receive an acknowledgement email, and your name will be listed in the contributor list in the open platform. So if you are interested in, you can visit this website here, Cornerstone Open Platform, where we share how you can upload your own device, what are the steps to follow. So before finishing my talk, I like to mention about the training opportunities. If you haven't heard about Peak Bootcamp, um, uh, we have several different partners where the Peak Bootcamp offers two different modules for peak training. One is enthusiast and the other one the practitioner, where in enthusiast module you will have some peak introduction which will be online and provided by Cornerstone, and the next will be the simulation training given by um, Synopsys and Lucida Photonics together. But even if you are interested in more in learning about peaks, then the practitioner will continue with the peak design training provided by Wave Photonics, and then followed by the fabrication right in Southampton by Cornerstone. And then the last training will be about the packaging by Photonics. Please visit that website if you are interested in learning more in photonic integrated circuits. And if you follow this practitioner module at the end of it, then you will have chance to get 25% of discount for the upcoming MPW run. So I'd like to thank you for listening, and if you have any questions, I'm happy to answer.
Thank you, Emre. You guys can all hear me, I think. So we already got a question, but I think we can move to Matt for now. And then Matt will give a demo of the PDK management platform, showing designers how they can easily access or discover and request the PDKs from Cornerstone, and how foundries also manage their PDKs efficiently through the Wave Photonics PDK management platform. So after that, we are going to do a Q&A round. I'm already collecting all the questions. So all the attendees, if you have any questions, please post them in the Q&A box. We will discuss them at the end of Matt's presentation. So Matt, I think you can take it away.
Awesome, thanks very much. And yeah, thanks for the overview of Cornerstone, Emre. It's always informative. Let me just share my screen. Yeah, so hopefully everyone can see my screen now.
Still loading. Yeah, you can see your screen.
Is that good? Awesome. So yeah, hi everyone. I'm just gonna say a few words about the PDK management platform that we've developed here at Wave Photonics and is now being used by Cornerstone. And so just before I get into sort of giving you a quick demo of that, just a few words on the context and where the PDK management platform came from. And that was really from the development that we did internally for ourselves. So if you know or don't know, Wave Photonics is primarily designing and optimizing photonic integrated circuit components, and we're building a technology that makes that barrier for design much lower by making sort of core technology that is rapid to design for new material processes and new wavelengths. And as part of that process, we wanted to make those component libraries and PDKs available to the designers in the least friction way possible. And that includes having those PDKs sort of accessible in the different EDA tools so that you can start using them in your current design flows as quickly as possible. And so what that meant is we ended up building a lot of infrastructure for taking those component libraries, having a system for versioning them, having a system for generating the S parameters, which are used for compact models, and then wrapping that all up and publishing it to a website where a user can just simply log in and download to access. And whilst we were developing this, we sort of realized that the pain points we were solving for ourselves would also be a pain point that presumably the foundries were also trying to solve as well. And indeed, that's something that with a few discussions of some different foundry partners that we in fact came across was the case. And so this prompted us to make this management platform more widely available and have it such that a foundry can use it to easily upload their PDK, have it run through the infrastructure that Wave Photonics has developed to generate those S parameters for the component designs, have everything wrapped into the EDA plugins, and have that available to the foundry's customers. And so today I'm just going to give a quick demo of how that looks from firstly the foundry experience, so using the portal to log in as a foundry and seeing how you can go about uploading a PDK and making it available where it runs through this pipeline that I've described. And then I'll also show from the designer side or from the foundry customer side how you use the platform to basically find the PDK that you want to use, download the correct package for the EDA tool that you'd like, and then a quick demo of how easy that is to install in your chosen tool and to get started with a quick circuit design. Now, it's worth just mentioning that Cornerstone, as you heard from Emery, it's a open source, open access foundry. So there's license free, and everything is sort of openly accessible and really easy to get designing with. For other foundries, that's not typically the case, and you might need to go through some sort of NDA process. And our platform has built in some features that can handle that and takes care of some of that process for you. Again, with the idea of trying to make it as easy to access and as frictionless as possible. So just before I jump into that demo, what I'll be showing you is essentially how you can just upload this PDK, as I mentioned, and then sort of the bit that happens behind the scenes is it gets run through this pipeline that I've described, and there is where we sort of have this automatic mapping to the EDA tools. We also have the capability for the black boxing of those components and for IP protection. Again, for Cornerstone, and that wasn't something that was useful there because they were wanting to have this open source PDK where everything is easily accessible and you can see the designs and use them as a starting for your own design. Again, other foundries, maybe that's more of a sensitive is something where you want to protect the IP from the end user, and that's a capability that we can. The components then have compact models generated by running some S parameter simulations for them. And as a part of this process, the documentation is automatically generated for each of those different PDKs. It then gets pushed to the website where users can access it. And as I mentioned previously, there are some of the controls available for sort of preventing automated access. And so with that, let me just jump across to the portal. So this is a sort of a demo account from the Foundry perspective, but here we've got our demo Foundry Photon Fab, and this is the sort of homepage that you see when you log into that. And so the thing to notice first is that we have sort of the part of the website which is you might be familiar with, which a standard user can sort of access. But now we also see this sort of extra set of features here, which is for the admin user of the portal. And so you can simply just go to the PDK uploader and you enter this table. You then have this button down at the bottom, which is the PDK upload. You can then drag and drop a zip folder containing the PDK in a template that we've helped to formulate, which is making it as easy as possible to sort of specify the contents of the PDK, so the different component GDS files, the DRC macro, the lib files for these sort of layer definitions. And there's more information on that in the template that you can download, and we can help you populate that template in the correct format. But once you drag and drop the zip onto there, it gets validated on upload, and then it enters the pipeline that I was describing earlier. And from there, the PDK is then generated and pushed to the website as a package. And so if I then go to the live website, so this is going to the cornerstone.wavephotonics.com that Emery mentioned. So as a designer, so this is the designer experience now. When you log in, again, you face with the homepage. To find the PDK that you'd like to use, you simply go to the hub, and you'll see that there are the different Cornerstone PDKs that Emery described in his talk available for you. And so if we want to look at the new 200 nanometer silicon nitride, all we need to do is simply request it. Because it's open source and open access, you'll see that it's granted immediately. That PDK then shows up in our PDKs panel, and we can see that we can view that. Here then you see all the different EDA tools that we've made available for this. And for example, if we want to look at the Lucida IPKIS one, we can then simply download that. And just to show how easy it now is to install, if I bring up my Lucida Control Center, I can then just simply add the downloaded zip file into that, and that should install the silicon nitride 200 nanometer PDK in Lucida, as you can see there. And now if I just bring my script across, so this is a sort of fairly basic script that I prepared earlier, which is using Lucida IPCAS to sort of demo the design of a Mach-Zehnder interferometer, so the component that Emre was talking about in his talk. You'll see that this is a Python-based tool that makes it very easy to do the layout using Python. And all we need to do to start using the PDK is to import the silicon nitride PDK into our environment. We then use the Lucida IPCAS tool to create our MZI class, where we define a property that we want to parameterize this circuit by. In this case, we've chosen the path length difference between the two arms of the MZI. We then define the components that we'd like to use from the PDK within this. And so you can see we've specified an MMI, and here we've chosen the 780 nanometers 2x1 MMI and the grating coupler at 780. We then simply define the different instances that we'd like of those components in the circuit. So we can see that we want an input grating and an output grating, and then an input splitter MMI and a combiner MMI. You can then place those different instances on a circuit and join them together, in this case using a simple Manhattan routing between the components. And the major benefit of accessing the PDK through the Wave Photonics platform is because the compact models and the S parameters are sort of shipped with those PDKs. You can then simply define your circuit in IPCAS and already get going with simulating that circuit using the Lucida circuit modeling tool. So now if I just run this, it'll take a second to do the layout and run the simulation. And what we should see shortly will be the simulation of the Mach-Zehnder interferometer. Now we can see the output of the simulation, where we've plotted the Mach-Zehnder, and you can see there's the MMIs with the difference in path length. And because of the S parameters that we've shipped with the PDK, you can now simulate this Mach-Zehnder, and you'll see that we've got the expected behavior for this component. And yeah, so that's the demo of the PDK and the upload tool, and how the designer can then access and use that. There is also a feature that we've begun working on to implement from the customer and the designer side, which is the mask submission. So that's sort of trying to make the process of submitting your mask design to the foundry a little bit smoother. This isn't enabled with Cornerstone as they already have a good system in place, but the idea here is that we have a similar process where you can simply have a GDS upload. You'll be able to select you'll be able to drag and drop your GDS file there, give it a name, and select which PDK that it's being uploaded for. You can then submit that, and in the background it runs the DRC and gives you some feedback in terms of the DRC before you submit it to the foundry. And yeah, from my side, that's everything for the demo that I wanted to show today. Apologies for the inevitable problems on running code live.
Yeah, no, that's that could happen anytime. That's unfortunate. All right, so thank you both for those presentations. And for the very informative presentations, especially from Emre, who just showed us all the platforms available and how they can be accessed. And also the PDK management platform by Matt. You can download Cornerstone's PDKs from cornerstone.wavephotonics.com. So now let's see if you have any questions from the audience. We already have one question. It's actually a three-part question. I think this question is for Emre. So what is the propagation? The Wakas Ahmed asked this question. So his question is, what is the propagation loss in for
Mhm.
a 200 nanometer thick silicon nitride waveguide operating at a wavelength of 780 nanometers as
Mhm.
compared to 300 nanometers thick silicon nitride.
Yeah, so we expect 5 dB and less, 5 dB per centimeter and less propagation loss in 200 nanometer. Thank you for the question, Ahmed. Um, but this run is the first MPW run. So we don't have test results yet. This is our expectation. And when you compare to 300 nanometer thick silicon, where we have more concrete building blocks for O band and C band, there we have consistent results that propagation losses are kept below zero point 0.6 dB per centimeter. For nominal, uh, actually, you can think kind of zero point 0.4 dB per centimeter, we get consistent results, but we aim at least having lower than zero point 0.6 dB per centimeter in MPW runs. It's just because it may change from wafer to wafer, from batch to batch, but our maximum acceptance criteria in 300 nanometer thick silicon nitride is zero point 0.6 dB per centimeter. For the new platform, I see also other questions about the watt level, optical power, um, about the degradation, so maybe the known damage or power threshold. Ahmed, these are all still to be known by us. We usually operate our systems low uh, power level, not high level. So we have actually quite limited knowledge in this field. But I can actually later share with you a contact person, uh, Dr. Talia Dominguez Buccio, who is working on the silicon nitride platform, and she is actually the main developer. So she may actually address your questions about high power, but in our labs we do usually like telecom wise uh, power levels. Okay, I think it's
Yeah, the next question is for Matt. Matt, can you read the Q&A screen?
Yeah. So the question for Wave is, do we also provide the S parameters for active components is the first question. So as you saw from Emre's talk, he was highlighted the active platform, which is targeting design of modulators and high-speed modulators. Obviously, to do the circuit design and simulation for that, you'd like to access the circuit modeling of the active element of that. Right now, the Wave Photonics platform doesn't support the active components, but that's something that we're obviously working on to try and integrate with. The second question there for Wave is can designers use other third-party component libraries within the same environment? So that's a good question. So this would be the use case of if you're using multiple different component libraries from different vendors, so maybe using the Fab PDK, maybe you have your own library or from a third party. And that is actually tool dependent. So it's one of the limitations by some of the different tools in the EDA software that you can use. What we've tried to do from our side is where the tool can support having multiple libraries loaded in the environment at the same time. We've made sure that we can enable that. But obviously, if the tool doesn't support that, then that's not something that we can address. And then, yeah, I think there's a question for you there, Emre.
yeah, for Cornerstone. It's also a really good question. Is there any selection criteria for the designs to contribute the Open PDK? So this is something also we have had some discussions with the delegates at ECOC, like when the people came to our booth and discuss about this open platform. So um, we want to be as much as inclusive as possible for the contributions. Um, of course, we expect the contribution brings maybe innovation or a better performance of existing components that are provided by support materials, supportive materials like a paper or even white papers are okay. So we don't want to exclude any for now, but this is something that we need to think still in the future to formulate properly. So the most important part is also the IP issues that we don't want to actually get in trouble. So when you do these contributions, I mentioned that checklist. So in the checklist, you actually support your contribution, saying that this is my own design, and I think this is useful for this kind of properties, and these are my data. Then it will be actually added into open platform. If it is something really incremental performance, let's say incremental improvement in terms of performance, it can be still in the open platform, but we encourage mostly bring kind of more innovation, some new devices, or also improved performances. This is something we need to still work and finalize properly. This is just the initiative, but this kind of questions we receive, and I think not only Cornerstone, but all together we should think and for the future and create this open platform more robust and let's say running smoothly.
Great. I don't see any questions. Does anyone have any other questions? Please feel free to post them in the Q&A box. All right, so I don't see any other questions. So yeah, thank you both for those very informative and insightful presentation. I also see someone is clapping. So yeah, so if you'd like to learn more about Cornerstone's PDKs or explore Wave Photonics PDK management platform, visit wavephotonics.com or cornerstone.wavephotonics.com. And if you want to learn more about Cornerstone, please visit cornerstone.sotonfab.co.uk. Thanks again, and thank you everyone who have joined today, and enjoy the rest of the day. Bye.
Thank you.
Cheers. Thank you.